All right, guys. So we're going to go on and get started on chapter 1.4. Because I think we answered most of the questions on the homework yesterday.
Right. Can you come look at these? I don't know if I got the right answers. I feel like I did it wrong.
Which one?
Most of the bottom ones. Well, this one's fine, but just like most of them. Oh, this one?
Well, it needs the starting equation.
I don't even have it.
Because you got 3 seconds, yes?
Yeah.
Okay. Because this would be the other half, and then $3. So this is $1.50, 2, 3, 4, 5.
Thank you.
You're welcome.
It was for reals. I say go for it, honestly. This ain't a green flag.
Because you need to check that one.
I was thinking it's either, or me and Isaiah were going through it. We were thinking it was on number 19, Isaiah, was it 4x or something?
Because 2 times 2 is?
Yeah, that's what we were saying. If we added it or multiplied it. So
Yes.
I thought
I'm pretty sure it's multiplied.
Because 19 is asking for a horizontal shrink. So we have g of x is equal to f of ax. Now, since it's a vertical shrink by a factor of 1/2, a is 2. Now, it told us the function is equal to the absolute value of 2x plus 4. And again, at this point, we're going to plug in 2x in every place that there is in x. Now we do need to multiply those two together, which would give us.
Somehow I got 5.
Yeah. All right.
yeah, that's right.
And then I struggled with.
Yeah.
You said chicken.
27, the original function is f of x equals x. Now the first one is a vertical stretch by a factor of 2. And our value of a is? And f of x is just x. So we have. Now the next transformation is followed by 1 unit up. So that will be our g of x plus k. Now what's the value of k? And it was up, so it's going to be plus 1. And the function we put in place of g of x is 2x, since there's no like terms. Any other questions before we get started? Now what we're looking at today is equations of a line. Looking at equations of lines. Now there's 2 main forms that we'll be looking at and using to find the equation of a line. The first one is slope-intercept form. And part of the reason they call it slope-intercept form is, well, the 2 parts of this equation besides the y and x is m and b. Yes. So this is something that y'all should have covered in Algebra 1 or at least a few times earlier than that. But the m represents our slope and the b is the y-intercept. So they literally called it exactly what it is because it contains the slope and y-intercept. So it's slope-intercept form. The other main one that's helpful is point-slope form. Well, again, it has m, which is the slope, and x1, y1 is a point. Slope-intercept is our y equals mx plus b. Bless you. And our point slope is our y minus y1 equals m times x minus x1. And the other important formula to know is our slope. Now the slope formula, m, is our change in y over change in x. Or a better way we know it is y2 minus y1 over x2 minus x1 is our slope formula. Any questions on any of this here? Now there is something called two-point form, which looks very similar to point slope, except instead of having m, we have slope written in. I would not use this form. It's not so much complicated. There's just a lot of stuff we have going on. Because if we are given 2 points, you're better off just finding the slope and then using point slope. I would not default to that because there's too much going on all at once. So if we are given 2 points, find the slope, plug it into point slope, and then you can find the equation of a line. Any questions on this here? Now the first problem we're going to look at in finding the equation of a line is this one here. The graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of the line and interpret the slope. This asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? So first thing we need to do is find the equation of a line. So eventually, we want to get the equation in the form of y equals mx plus b. Now, if we're given the y-intercept, we can go straight to this form here. If not, then we have to use point-slope form. Now, looking at the chart, or looking at this graph, we are explicitly given 1 point, 524. We're actually also given another point. It's just not labeled. What's our other point? 0, 0. So we do have 2 points. One is 524, the other is 0, 0, which also means that the y-intercept is what? The point 0, 0. So the y-intercept's value is 0, which is helpful because it means for this equation here, the value b is 0. Now we need to find the slope. So what are our two y values? .524 is a point, and every point comes in the form of x comma 24 and 0. Which one do we want to put first? Doesn't matter, because we can put 0 first and then 24 second. Because the order in which we put the y values isn't overly important, but the x values have to match. So since I put 0 first, what's the x value that corresponds with that y value? 0. Because the point is that we have is 0, 0, and 524, yes? So the y value that has 0, x value is 0, because it's this point here. 24 went second, and its x value is 5. They have to match up. Since we use 0 first, we use its x value first. Since we use 24 second, we use its x value second. And now we need to simplify this. Well, 0 minus 24 is 0 minus 5 is negative 5, which gives us 24 over 5. So the slope is 24 over 5. And we can plug that back in, telling us the equation of a line is y equals 24 over 5x. Questions on how we found the equation of a line? As we found that. Because every equation, we need to get it to that form. Even if we're given a point and the slope, we start with point slope, we're going to need to get it into slope intercept.
I just seen the word up there. It says
Right, an equation of a line. And interpret the slope. So we still need to interpret the slope. Interpret the slope is just saying, what does the slope tell us? What does 24 over 5 mean in context of this problem? So the 5 is what? Time. So what we're saying is for every 5 seconds, it travels how far? Travels 24 miles. Do we say that's fast? Because even taking, I think, the longest, I mean, not longest, but taking a longer route, I don't think from here to Siloam is quite 24 miles if we go to 412 and then over. And as the crow flies going a straight distance, it's definitely not 24 miles, so we can make it from here to Siloam in less than 5 seconds if we were traveling this fast. I think 24 miles might be the distance from here to Fayetteville. So, questions on how we found the equation of the line or interpreted the slope? Is there anything else this problem is asking for? We got that. So how long does it take to travel this distance? So what distance is it asking about? Yes, it came. Well, we only got one distance. It was 17,200 miles, yes? So we have to plug this into the equation. So the 17,200, are we going to plug it in for x or y? It would be y, because y is our what? What have we defined y as? Distance, yeah. So we're saying y is distance, x is time. So we'll take this equation and plug in 17,200 miles. And we're going to solve for the value of x. How can we get x by itself? We can move it over. So what operation will we need to do to move the 24 over 5? We can multiply, we can also what? I think I heard something, I don't know. Might be hearing things. Because what can we multiply by? So we need to get rid of the 24 over 5, yes? So we can't multiply by 24 over 5. So we can multiply by what? 5 over 24. Clear all that out. Let's clear all that up. Because we have 24 over 5. If I multiply it by 5 over 24, what do we get? 1. And this is really the identity property of multiplication, that a times 1 over a will equal 1. But if I do it to one side, we have to do it to the other. So these here will cancel, leaving us with x by itself. On the other side, we have to do 17,200 multiplied by 5/24, which is 3,583.3 repeated. Which is really just 1/3. It's how many seconds it would take to travel 17,200 miles. Well, we can do that. Now, I'm going to go back and do this a little bit differently, but are there any questions on this so far? So, I'm going to back up. How is x and 24 over 5, what is the operation sticking them together? Are they being added, subtracted, multiplied, divided? 24 over 5 and x, that fraction in x. They're being multiplied, so how can I undo multiplication? So what's the opposite of multiplying? We would divide. So what I could do is I could divide both sides by 24 over 5. I'm going to pull the calculator back up. So I could say 17,200 over 24 over 5. Well, originally we got 3,583.3 repeated. We do the exact same thing. We could do it either way. Yeah, so we can multiply it by the reciprocal of the fraction and get our answer, or we can just divide by that fraction. And we get the exact same thing. Questions on this here? And it's just under 1 hour. We calculated that earlier today, but also there's 3,600 seconds in a minute. 60 squared. Any questions on this problem? We ready for the next one? The graph shows the remaining balance y on a car loan after X months. Get a highlighter. Write an equation of a line and interpret the slope and y-intercept. And what is the remaining balance after 36 payments? What do we think? Do you think there's going to be a balance after 36 payments? Or do you think they'll pay it off in 36 months? So does the graph support it being able to be paid off in 36 months? No. It's going to pay it off in 60. Yes? Does that make sense? And again, that's kind of a side note, but especially with the ACT science section, just reading a graph. Because if I want to disprove the claim that they could pay it off in 36 months, well, no, graph. This one here, whatever they would label it, does not support it because it shows it above the x-axis. It's going to take them more than 36 months to pay it off. Now, we need to write the equation of a line. And even if we start out at point slope, we will need to eventually get to y equals mx plus b. That's the one we need to get to eventually. Now, looking at the information they gave us 2 points, 0, 18, and 10, 15. And it would be nice if one of these is the y-intercept. Do we have the y-intercept? 0, 18. One of the key giveaways is that it is intersecting the y-axis, but also the x value of a y-intercept is always what? 0. What is the y value of the x-intercept? 0. Because if it crosses the x-axis, the y value has to be 0. If it crosses the y-axis, the x value is 0. And if it crosses the origin, they're both 0. So we are given the y-intercept, which tells us the value of b for this is what? Where does it cross the y-axis at? Because this is our y-axis, so it crosses at 0, 18. So the b value is 18. But we still need to find the slope. Yes. Now we could do it the other way. I will write this on the whiteboard because instead of 18 first, we could have said 15 minus 18 over 10 minus 0.
Does it matter?
Let's see. On the other side. So our first part, 18 minus 15 is 3. 0 minus 10 is negative 10. So it's the same as negative 3/10 to negative 0.3. Now, if we look at the other one and did the subtraction, the numerator 15 minus 18 is negative 3. 10 minus 0 is, did we get the same answer? Yeah.
Oh, good.
Now, the main thing with this here is that we don't switch up the values, that we don't put 18 minus 15 over 10 minus 0. Whatever y value goes first, its corresponding x value has to go first. And vice versa. So we get this here. So we found our equation of a line. Now we need to interpret the slope. So we can use negative 3/10. So for every 10 payments, the amount goes up or down. Amount goes down. Really hope it doesn't go up. By how much? How much would it go down by? So our equation, we're looking at the slope. It goes down by 3, yes? Does that seem right? For every 10 payments you make on this car, the amount goes down by $3. Look back at our y-axis. What does it tell us? It's balance, but I think there's something else there. What else does it include? What are our units? Balance is in what? Exactly. Thousands of. So is it really going down by $3? $3. 3,000. Now, per month, it is going down by 300. So we could have also said for every payment, the amount goes down by $300. For every 10 months, it's going down by 3,000. Those are saying the same thing. We just can't mix them up because I can't say for every 10 payments the amount is going down by $300 because that's not true. And I can't say for every payment the amount is going down by $3,000. The latter is true if you're making additional payments on top of the normal payment, but we have this here. Any questions on this so far? So we wrote the equation of the line, yes? We interpreted the slope, yes? So we can move on to the next part, which is what? So what does the y-intercept tell me? 0, 18. Well, 0 is the, so if I have 0 payments, have we paid anything on it? So what does the 18 tell us? That much, how much the car is, how much the original cost. Yeah, we could say the original cost of the car. Or we could say the starting amount of the car. This is how much the car was worth. Depending on the car, you can actually get a pretty nice car for 18 grand. Maybe. Because it's been 6 years now, but as the orange car I drive, me and my wife drive, was 18,000 originally. Yeah, no, price of cars now is very hard to find a car at 18,000. That's not used. But there are some out there. But that's the original price of the car, and you would pay it off going this far out. Now, okay, we did that. Now we need to what? What is the remaining balance after 36 payments? Y or X? Which one would we plug the 36 into? X, because X is our number of, and Y is the balance. So we'd have negative 3/10 times 36 plus 18. Is the variable by itself? Well, is the variable by itself? Can we say that's true? Yeah, so everything on here is just straight numbers. So we can, yeah, I can say negative 3/10 times 36 plus 18 is 36 over 5. Now the button above enter, the two arrows that face away from each other, goes fraction to decimal or decimal to fraction. We can switch between them. So it tells us that our y value is 7.2, which is $7,200. Questions on any of this here? Now this is more, the next thing I'm going to say is more PFL than it is Algebra 2, but it is very unadvisable. I'd be beyond unadvisable. Just don't get a car loan for more than 5 years. It is possible. They will give you a car loan for more than 5 years. Just don't do it. What's going to most likely happen, the closer or farther out past 5 years you go, you run the risk of being upside down on your loan, which means after 5 years, let's say you have $2,000 left on it, the likelihood that that car is going to be at least $2,000 is not high, because it could be that the car is only worth $1,000. But this is called being upside down, because if you either A, sold it, or B, it got totaled and the insurance paid you with what it's worth, they would pay you the $1,000. But you can put into paying off part of this, but you would still owe $1,000 on a car you don't own anymore. That's called being upside down, when you owe more than what it's worth. You can do that on cars, you can do it on houses, you can do it on a lot of things. If you do not want to be upside down on anything, if you could avoid it. But that is that. Let's look at this next one. Hiking. The graph shows the distance Allison hikes in X hours. Write an equation of the line and interpret the slope. I don't know why I wrote it that way. So let's scroll down just a little bit further. So we have this here. We want to write the equation in y equals mx plus b. We will need to find the slope. Now, again, they gave us 2 points. One of our 2 points is 7, 24.5. What is the other? 0, 0. Well, since they gave us 0, 0, I know the value of b is going to be what? 0. So really, we just need to find the slope. So we do have 2 y values. What's one of them? 24.5. Or you can say 24.5 minus 0. What's our first x value that we're going to plug into this equation? And the other is 0. Now for this one here, we could plug this straight into a calculator. 24.5 over 7 minus 0 is 3.5. So our slope is 3.5, which means our equation is 3.5x. So we have the equation. Now we need to interpret the slope. So the slope is telling us she's traveling 3.5 miles, well, the per hour, because there's not a number there, it's understood to be 1. Almost.
Wait, why is it?
Because this is miles, this is hours, because we're interpreting the slope. So for every hour, she hikes how far? 3.5 miles. Okay. So we've interpreted the slope, and we found the equation of a line. Now we need to see how long it's going to take her to travel 14 miles. Now, is the 14 going to be inputted for the x, or are we going to input it for the y? Because which one's miles? X or y? Y. So it'd be 14 is equal to 3.5 x. And to finish solving this problem, what will we need to do? By? Yep, 14 divided by 3.5. Well, it's not like 4. It is 4. 14 divided by 3.5 is 4. Is exactly 4. Yeah. Well, another way we can look at it is 3.5 is every hour, so 2 hours. 3.5 plus 3.5 is 7. So in 2 hours, she can travel 7 miles. We double that. 7 doubles 14. 2 doubles is 4.
How fast is she walking?
y equals 3.5x is the equation of the line. We're going to stop there because we won't have enough time to finish this next one, but we will do it tomorrow.